Okay, so I hope that you started to get a pretty good understanding of 45, 45, 90 triangles. This is also this should actually be like 6.3b, but that's neither here nor there. So we're still talking about a special right triangle, okay? And 45, 45, 90 triangles follow a specific pattern, right? You're dealing with the right triangle, so that means that a 90-degree angle is going to be involved, and you're dealing with a triangle, so there's going to be three sides. Now, we've spoken about a 45, 45, 90. This is a 30, 60, 90, and it's a little bit more complicated, but again, there is some work to be done, and there are some things that you have to think about. And again, these are the angle measures of that triangle. Okay, so 30, 60, 90 is going to be the angle measures of the triangle. And that's how you can determine that it is special. And again, these are very specific types of triangles. Okay, they fit into a very specific category, and that category is it has to be a right triangle, and it also has to have these specific angle measures. Okay, much like the 45, 45, 90, you had to have exactly 45, 45, 90 triangles in order to follow that pattern. And this is similar. So consider an equilateral triangle. So equilateral, all three sides equal. How could you find this height? Okay, so for an equilateral triangle, every angle is 60. And when I draw this altitude, I split this into 30 and 30. And what I end up doing is creating right triangles right there. All right, now another way to think about this is what would happen if my hypotenuse was double one leg? And here's what I mean when I say that. Okay, what would happen there? So let's just, for argument's sake, say I've got a hypotenuse, and we'll just say that it's 2, and one of the legs is 1. Okay, this happens in a 30, 60, 90 triangle. Okay, now let's just consider Pythagorean theorem. Okay, I have my hypotenuse. Okay, 2 and 1 is about as simple as it gets for being double one side. So, and I have one leg. Okay, so now let's just do Pythagorean theorem. So 1 squared plus b squared will equal 2 squared. So that'll be 1, b squared equals 4. So b squared equals 3, so b will equal square root of 3. And please leave it like this, okay? Please leave it like that. Please don't type in and give me a big, long, ugly decimal. Please don't do that. Please just give me square root of 3. That's a much cleaner, much simpler, and actually much more correct representation of that number. Okay, so you follow this idea of this is 1, this is 2, this is square root of 3. Consider... Well, let's look at something else. So let's look at another example. So consider I have, again, an hypotenuse that is double the short side. So let's just say, for argument's sake, that this is 6, and this one's going to be 3. So this is going to be a 30, 60, 90. Now, please take a moment. Notice, okay, the hypotenuse is across from 90 degrees. Okay, the leg that is half of the hypotenuse is across from the 30. And the middle side is across from 60. Okay, so this would be considered my short side. This one is considered my hypotenuse. All right, once again, forgive me. My handwriting is questionable on the best of days, especially on an iPad. That's the hypotenuse. That's the short side. This, most oftentimes, is sometimes called the long leg, or just the middle side. Okay, that's what this is often called, long leg or the middle side. So again, let's follow Pythagorean theorem and see where it takes us. So this becomes 9 and 36. So b squared will equal 27. So b will equal square root of 27. So if we recall from before, well, let's see if we can simplify this. So this becomes 9 and 3. So it becomes square root of 9 times square root of 3. Well, the square root of 9 is 3, so that becomes 3 square root of 3. So here we had 1, and we just had square root of 3. Here we have 3, and that becomes 3 square root of 3. And I wonder if a pattern might start to emerge. And believe it or not, it actually does. So when you have a 30, 60, 90, okay, what you need to consider is that 30 degrees is across from the short leg. All right, this is considered the long leg. And this one is still my hypotenuse, my good old hypotenuse, the steady hypotenuse. And what you need to realize is that a pattern does emerge, and the pattern goes like this. So for 45, 45, 90, the pattern was simply x, x, x square root of 2. 30, 60, 90 is a little bit trickier. First off, we've established that the short side is always going to be half of the long side. So whatever my short side is going to be half of the long side. And the hypotenuse is always going to be double the short side. So if you know one of those, then life is not too difficult. For that middle term, we figured out that a square root of 3 will be involved. And what happens is that it ends up being the short side times the square root of 3. Okay, so it ends up being the short side times the square root of 3. So let's look at some of these scenarios here. So you're given the hypotenuse. You're given the longest side, and you have to figure out the long leg. So you have 2x, and you want to figure out x square root of 3. Well, how would I get from here to here? It wouldn't be too terrible. I mean, I would divide by 2 and then multiply it by square root of 3. All right, that's kind of what I would do to figure that out. How would I get from 2x to x squared root of 3? Well, I would divide by 2, and then I would multiply by square root of 3. And I believe I can write that better. So I would multiply by square root of 3. So that would be my step there. If you're given the short leg, you're trying to find the hypotenuse. Okay, so you're given the short leg, x. You're trying to find the hypotenuse, which is 2x. And that's not too terrible. All I really need to do is multiply by 2. Okay, multiply by 2, and that will give me my hypotenuse. To find the short leg, if we're given the short leg, find the long leg. So you have x, and you have x square root of 3. Again, not too terrible. I'm just going to simply multiply by square root of 3. And I'm going to leave my answer like that. So now if I'm given the long leg, so that would be x square root of 3. To find the short leg is just x. Okay, my short leg is just the x leg. I'm going to need to divide by square root of 3. And I would caution you here, this might require a rationalization step. Okay, we talked a little bit about that in 45, 45, 90. Square root of 3 is still irrational, so you might have to do that multiply by 1 thing and kind of figure out what that might look like simplified. Okay, so be aware that that's there. And we'll take a look at kind of what we're doing here. So a long leg, x square root of 3, to find the hypotenuse, 2x. So this is going to be similar to the one above it. So I'm going to divide by square root of 3. And then I'm also going to multiply by 2. Okay, so I'm going to divide square root of 3, multiply by 2. All right, so these two are definitely the trickiest ones to handle. Okay, those two are definitely the trickiest ones to handle. The other ones don't require too much trickery or too much concentration. If you're given the hypotenuse 2x, find the short leg, which is just x. This one's not too terrible. You find the hypotenuse, you're merely going to divide by 2 there. That one's not too bad. Okay, so if I were you, I would definitely keep this handy somewhere. Okay, so now let's take a look at what we have here. Well, we're looking for x, which is my short side. We're looking for y, which is my hypotenuse. Okay, so we're given long leg. And from there, we need to figure out the other two sides. Okay, so I'm going to try to figure out short side first. Okay, y, short side first. I'm going to try and figure out the short side first, because if you look back at that table we filled out, all that happens is that I'm going to divide by the square root of 3. Okay, so if I consider, I've got this, I don't know why I started drawing my x's like that, but whatever. My long leg is 12. Okay, so my long leg is whatever my short side is times square root of 3. So I take x square root of 3 equals 12. So now this is where the rationalize step comes in, okay, because I'm going to solve. So that becomes 1. And similar to the 45, 45, 90 triangles, when we're talking about square root of 2, square root of 2 is irrational, as is square root of 3. Okay, recall that this is irrational. Okay, that means no end and never repeats. No end and never repeats. That's an irrational number. So again, you cannot take unit 12, or not unit 12. You cannot take 12, a quantity of 12, divided by something that never ends and never repeats. So we work around that by multiplying by 1. Okay, same thing top and bottom, fraction rules, that's technically 1. So when I do that, I end up with 12 square root of 3 over 3. Similar to before, square root of 3 times 3 is just square root of 9, which is merely 3. So now I can do a little bit of simplification here. So 12 over 3 will merely be 4 square root of 3. Okay, so now that's my simplified answer. So now realize this is my short side. Okay, that's going to be what x is. Now, realize that to find my hypotenuse, I just need to take 4 square root of 3 times 2, which is merely 8 square root of 3. Once you have the square root of 3, you can multiply the numbers outside of it. It's not that big of an issue. You just leave it as, just kind of bring the square root of 3 along. So that will be my hypotenuse. But Mr. Heeren, something is wrong here. This leg is bigger than the hypotenuse because, and the hypotenuse has always got to be the biggest side. That's what you told us way back in like unit 3. What you are saying is correct, but realize this is the quantity 12. This is 8 times square root of 3. This is not just 8, and this is often confusing. 8 square root of 3, you plug it in a calculator, okay? You look at the big, long, ugly decimal, and it's going to be greater than 12. So I'm still okay there. Okay, so it's going to be greater than 12. I'm still okay. Even though it looks 8 square root of 3, even though it looks smaller than 12, it is actually going to be okay there. Okay, so now let's look. All right, so here, so that's a 60. That makes that 30. That makes this my short leg. That makes this the long leg. That makes this one the hypotenuse. Okay, so I'm given the hypotenuse. So I'm given this long side. So long side, my hypotenuse, not long leg, sorry, don't confuse the two. My long leg is 10, or my hypotenuse is 10. So I merely have to divide by 2 to get my short leg. So that's going to be 5. So really easy. Short leg is 5. So then to get the middle leg, I'm going to take my short leg times square root of 3. Well, it's just 5 square root of 3. I can leave it like that. I don't need big, long, ugly decimal, okay? No big, long, ugly decimal looking thing. It's lazy mathematics doing that, okay? Don't do that. So that would be my answer. It's not too terrible. So now here's a little bit of a tricky one, okay? So we're okay though. So 30, so that makes this 60. That's 90. That makes this little one in here 60. Okay. So now let's consider what I have here. So here, they say that my hypotenuse is 2 square root of 3, and they want to know x, and then they want to know y. So I've got two 30, 60, 90s here, and I need to do a little bit I need to do a little bit of work to figure this out. All right, so I have my hypotenuse, but that is 2 square root of 3. Okay, so that's 2 square root of 3 there. Now to get my short side, I'm just going to divide by 2, which means my short side, which is this side, is square root of 3. Okay, so far so good. Nothing too brain-breaking, but I want the middle side. Okay, well the middle side says take whatever my short side is and times it by square root of 3. Okay, well, okay, so this gets a little bit weird because I have square root of 3 times square root of 3. Well, now exponent rules and root rules come into play, and that's just merely 3. So my middle side here is going to be 3. Okay, so we figured out x. Wonderful. So now I found out my short side because I knew I would need it later. Plus, it's way easier to do that than try and go directly from my hypotenuse to long leg. It's way easier just to go figure out the short side first. Here, from this perspective, down here, I'm given my long leg. And they want the short leg. So I'm given that my long leg is square root of 3. And they want this one. Well, remember that my long leg is merely my short leg times square root of 3. Okay, so long leg is whatever my short leg is times square root of 3. So when I divide there, well, this cancels out, but what happens over here? Well, this cancels out as well. Technically, it really doesn't cancel out. It becomes 1. So that's my answer. My answer is merely 1. So there's my answer. Okay, now very easy to get confused here. Very, very easy to get confused. So I tried to kind of divide it. All of this work kind of went with this larger triangle here on the left, and this work was kind of right here with that triangle. So anything you can do to kind of keep your work separated by which shape you're dealing with will help you stay organized. Or, you know, if you could always break this apart and draw one triangle, but then realize that they do share a side, and this side is my short leg on this triangle, but it's my middle leg on this triangle, my long leg on this triangle. Whatever you have to do to kind of keep it organized. Okay, so this presents a nice little challenge. So we have a 30, 60, 90, but we also have a 45, 45, 90. Okay, so let's talk about, I'll tell you what, we'll do the 30, 60, 90 in red. All right, and let's look at just this top triangle. Okay, and let's look what we got. So 30 is across from 9. Okay, so my short side is 9. Okay, and they want Z is the hypotenuse. Okay, so that's just going to be double. That's going to be 18. Boom, easy. But down here for this triangle, okay, I'm going to need what is considered my long leg from the top triangle. So that's simple enough. That's just whatever this is times square root of 3. So now that side is 9 square root of 3. But then when I consider it from the perspective of this angle, looking at, from this triangle, this is my hypotenuse. So for the 45 and 45, 90 triangle, my hypotenuse is 9 square root of 3. And they want to know how long are the legs going to be. Okay, well this will be interesting. This will be a good problem to look at. So I have, nope, not x square root of 3. I will have x square root of 2 equals 9 square root of 3. So now we will divide by square root of 2. Because again, that becomes 1. So x, 9 square root of 3 over 2, square root of 2. So now I have to rationalize, okay? So I'm going to multiply both the top and bottom, by the square root of 2, because that's in my denominator. That's my 1. So what happens, though, is this. So I get 9 square root of 3 times square root of 2 on the top, and then on the bottom I get square root of 2, square root of 2. Which we've established a couple times before that the bottom is going to merely be 2. So on the top, you know what? 9 stays there. I multiply the 3 and the 2 together because they're both underneath the square root, and I get that. And there's no simplifying square root of 6. That's what that gets. So that will be both legs. It's a wonderful problem. That's a great problem. It's a good mind-stretching problem. Okay, well, take some time with this. Okay, get used to working with the pattern. And again, the big one is, the big questions, you know, where do I start? What side do I know? And, you know, which side do I need to find? Okay, so that's working within both of these patterns here. Okay.